You'll often see this question towards the end of the math modules ranked hard difficulty, but it's not too bad once you know what to do, once you can recognize it. So I'm going to show you the quick way to solve this, and then I'll also show you some longer ways to solve this that will just give you some flexibility and maybe some insight into why the shortcut works. So let's start with the shortcut. We have here the system. We're told that this system should have no solutions, and we want to know the value of k that will make that happen. So the shortcut here is when you have your system of equations in this standard form of ax plus by equals c, when they're sort of stacked on top of each other, we can set up a proportion using the coefficients of the equation. And when there is either no solutions or infinite solutions, when we set up the proportion, we should set those ratios equal. So we should set the ratio of k to 4 equal to the ratio of the other coefficients, in this case, -3 and -5. And now we can solve this for k. And the value we get for k will make this ratio, make this proportion equal, and that will therefore make this have no solutions. So let's cross multiply. -5k is equal to -12. And so k would be 12 over 5, and that would get us choice A. If we go ahead and plug this value of k into the equation and plug these equations into Desmos, we can indeed verify that we have two parallel lines, and two parallel lines, of course, never intersect, meaning there's no solution to the system. In fact, this is another way you could have done this question. You could have actually just tested these choices for k in your system and see which one gives you parallel lines. If, for example, we try choice B, I'll change this to 16 over 7. They start to look parallel, but if we zoom out a little bit, we see that they do eventually intersect. So this system actually has one solution. And we'll see the rest of them either have one solution or, well, yeah, no, they're going to have one solution. So the only one that gives us no solutions, parallel lines, would be choice A. Now, don't 100% rely on the Desmos approach. All they would have to do is turn this question into one of those free response questions where they don't give you choices, and you wouldn't be able to just plug in. It is not a good idea to try to spam different k's and just hope you get lucky, because frankly, you'll never guess 12/5. I mean, you'll never plug in k as 12/5 on your own. So that's why it is important to know how to do it with Desmos. But Desmos is an option in multiple choice versions, and at the very least, you can check your answer like we did here. So those were the short options. What are some longer ways that maybe show why these methods are working? I mean, one thing you could try to do is treat this like solving a typical system where we either do substitution or elimination to solve the system. Now, I'm going to do elimination. I think substitution, it's fine, but especially in this case, it's going to be a little messy. And what I want to have happen is I want one of my terms to cancel so that I'm left with the other, and then we'll talk about what happens then. But what I'm going to do is I'm going to multiply, let's say, this top equation by -5 with an eye towards having the y's cancel out when I add them together. So let me write them out over here. So -5kx plus 15y is equal to -20, and then we have the other equation from before. Oh, and you know what? We're going to have to multiply this bottom one by 3 as well, right? Because that will allow the y's to cancel. So we're going to make this 12x minus 15y equals 21. Okay, so we're going to multiply the top by -5, bottom by +3, again with an eye towards when I add these equations together, having my 15y's cancel. So I'm going to get -5kx plus 12x equals 1. Now this is where you might get a little stuck if you're trying to do this method, because normally we wouldn't have this k. We'd be able to solve for a value of x. But the point is there is no value of x, right? This has no solutions. So how do we deal with that here? What we want to have happen to have no solutions is I want to end up with some result like this, 0 equals 1, or some number that isn't 1 equaling 1. This would be the no solutions case. So how's that going to happen in my problem? Well, it's going to happen when these terms cancel. In other words, when -5kx plus 12x cancels out to 0. In other words, we want, when we add these coefficients, we want -5k plus 12 to equal 0 so that x term cancels. And if I go ahead and solve this, -5k is equal to -12. Again, we get k is 12 over 5. So you might begin to see, going back to our shortcut, why the shortcut is working. By setting up this proportion, we're essentially trying to figure out what is the value of k that will make these two lines proportional to each other such that when you add them, they completely cancel. And so this gets us the same answer as well. A final way to do this that I think makes it most explicit as to what's going on here is to remember that when you have a system with no solutions, that means these lines are parallel, and that means their slopes are equal. Let's put these into y equals mx plus b form and see how we can compare their slopes. So for this top guy, I'm just going to move the 3y over here, and I'm going to move the 4 over here. So I'm going to get 3y is equal to kx minus 4. Then I'll divide through by the 3, and we get this. So k over 3x minus 4 over 3. That looks good, right? I think so. We'll do the same thing with this guy. Move the 5y over here, the 7 over here. So I'm going to get 5y is equal to 4x minus 7. And again, y is equal to 4 over 5x minus 7 over 5. Now, again, if these lines have no solutions, their slopes are equal. They're parallel. And so I should be able to set k over 3 equal to 4 over 5. And notice with a quick little rearrangement using the rules of algebra, we can get this version of this equation. And if I multiply top and bottom by -1, still equal, I recreate this ratio. So long story short, there's nothing wrong with doing the y equals mx plus b approach. It's just a long version of how we started out the problem with our shortcut. What the shortcut is basically doing when we set up that proportion is determining what is the value of k such that when I rearrange them in y equals mx plus b form, the sort of the ratios of those coefficients produce two equivalent slopes. So you could do the y equals mx plus b approach. It's just a longer version of the shortcut. So that's why the shortcut works. Definitely use the shortcut when you can, because it turns a problem like this into a pretty quick solve. So either way, we get choice A.